educational progress. Teachers, please be sure to check your attendance.
So get started on this warm-up. You're going to get so good at factor treeing these radicals or using your perfect square method if you want to use that method. All right, so here, yeah, you found it, I know, but we're just going to use RT. So here are the answers to the warm-up. Would you like me to factor tree one of these? Yes, which one, Adriel? Okay, let's do number 4. Very good. We'll do the one that has the largest number. So I talked about 2 different ways yesterday. I talked about the perfect square way, and I talked about the factor tree way. The perfect square way, if you've memorized your perfect squares and you have good number sense, you can think about what is the largest perfect square that will go into this number. So like for number 4, this is weird. Okay, for number 4, I know that 25 is a perfect square and 25 goes into 150. So I could write this as 25 times 6, because 25 times 6 is 150. Well, 25 is a perfect square. So that's just saying 2 times 5 root 6. And that's how we get 10 root 6. So that's one way. That's called the perfect square way if you have your good number sense. The factor tree way, maybe you didn't think of 25 and 6. Maybe you thought of 15 and 10. So then remember, you do a factor tree until you find a prime number. When you find a prime number, you circle it, and then you look for pairs. There was already a 2. I see a pair of 5s, so that one leaves jail. And then I see a 3 and a 2 without any pairs. A 3 and a 2 without any pairs. So then you just multiply your remaining ones together. 2 times 5 is 10, and 3 times 2 is 6. So whenever there are numbers left over inside the radical, or when there's more than one number outside the radical, you simply multiply them. You find their product. There are 3 whole pages of homework answers because it was a long homework. I hope that if you didn't do all the homework, I hope that you concentrated on the ones at the bottom, 22 and higher, or sorry, number 21 and higher, I'm hoping. Because the top was just drill and kill. It was just practicing with those radicals, but the bottom had you adding and subtracting radicals, which is an important skill that we learned yesterday. Here's 21 through 32 on the front, depending on which side was the front to you. Here are the answers to the other side, 1 through 24. One of the sides was 1 through 32, I think, and the other side is 1 through 24. Okay, Adriel, okay. So we're looking at 29 from the front of the worksheet. What we learned yesterday is that adding and subtracting radicals is just like adding and subtracting variables. If they are like terms, you're allowed to add them. If they are not like terms, you're not allowed to add and subtract them. So you want to look at the radicand. If the radicands match, you're allowed to add and subtract. Let's take a look at this one. This one is square root 3, and this one is square root 3. These are kind of like terms, kind of. They're the same radical, the same radicand. So, what is 8 minus 15? -7, very good. So if I have 8 cookies, and someone takes 15 cookies away from me, which is impossible, I would have -7 cookies, right? If I have 8 root 3s and someone takes 15 root 3s away from me, I have -7 root 3s. That's how many of them I have. This does not match. Root 6 does not match. You always check to see if you can simplify it, but 6 is 2 times 3. There's no pairs there. If there's no pairs, that means there's no perfect squares, so nothing can come out of the radical. What else can I work? All right, number 22 is a very commonly missed problem because people forget to square the 3. So I just want to go over this. I recommend every time you see this problem that you write 3 squared and then you write root 5 squared. I want you to distribute the exponent. It's not really called distributing, but I want you to write them separately. Both of them get squared. Okay, and then you just write what they each equal. 3 squared is 9. Square root of 5 squared, well, those cancel. Square root and square, those are inverse operations, so they cancel. So the answer to this problem is 9 times 5. The answer to this problem is 45. Okay, so now we're on 22 on the back of this practice. Neither of those radicals are in simplest form because they both contain perfect squares in them. So we need to factor tree both of these. So I would factor tree this. This is 4 times 2, prime number, so you circle it. 2 times 2, prime, prime, so you circle it. So there was already a 4 there, a 2 escapes, and a 2 is left over. Now I'm going to work on this one. 32, I'll do 8 times 4, 2 times 2, 4 times 2, only circle primes. It's a lot of 2's here. So we're only circling them when we get to a dead end. So on this one, plus, there was already a 3 there, a 2 escapes, another 2 escapes, and a 2 is left over. So let's simplify this. This first one, 4 times 2, is 8 root 2. And the second one is 3 times 2, which is 6. 6 times 2, which is 12. So this problem is saying 8 root 2 plus 12 root 2. Those radicands are the same. They're both radical 2. So I'm allowed to add them. If I have 8 of something and then I have 12 of something, then in total I have 20 of that thing. So that's why that one is 20 root 2. We're going to continue from yesterday's lesson working with radicals. First, we talked about how to add and subtract radicals, and I talked about how you can add 2x plus 3x, but you can't add 2x plus 4y. Now, we're going to look at multiplying and dividing radicals, and we're going to treat it the same way that we do variables, the same way. If I said, what is 2x times 3x, you would say it is oh no. 2x times 3x is 6x squared. So, how does that work? First, we multiply the numbers together. 2 times 3, 2 times 3, and you get 6. Then, we multiply the variables. X times x is x squared. So 2x times 3x is 6x squared. We're going to do the same thing with radicals. We're going to multiply the numbers outside the radicals separate from the numbers inside the radicals. What's the next one? 4y squared times 3y squared. So we're going to do 4 times 3. 4 times 3, 12. And then we're going to do y squared times y squared times y to the third. So we're multiplying the numbers on the outside separate from our square roots, separate from our radicands, okay? Okay. So here we go, multiplying radicals. Here's the rule. I already said this, you multiply the numbers on the outside separate from the numbers inside the radicals, separate from the radicands. So if we look at this first one, we do 3 times 4, just like we did. 3 times 4, 12. Then we are allowed, remember, you cannot add radicals that have separate radicands, but you can multiply radicals that have separate radicands. So now we're going to do square root 2 times square root 5, and that is square root 10. Yes, you're allowed to multiply them. You're not allowed to add them, but you are allowed to multiply them. Just like, if you ever forget, are you allowed to add these? No. Are you allowed to multiply these? Sure can. So x plus y is just x plus y. X times y is xy. You can multiply them, but you just can't add them. You can't combine them into one term, okay? The same for radicals. All right, what about this one down here? Square root of 7 times negative 2 root 4. Now, you may or may not see this, and you need to be really good at recognizing perfect squares, but there's a perfect square there. You see the square root 4? Square root 4 is just 2, right? So this is really saying square root of 7 times negative 2 times 2. Because the square root of 4 is just 2. So that is like saying the square root of 7, oops, I'm already putting times. That's like saying the square root of 7 times negative 4. So it's negative 4 root 7. Just like with x's, we always write the coefficient and then we write the letter x. Same goes here. We're going to write the integer, negative 4, and then we're going to write the radical, root 7. Negative 4 root 7. So that's how that one works. We simplified the negative 2 root 4 and then we just multiplied them. Okay. Now we're going to talk about dividing. This is no different than multiplying because you know that those go hand in hand. You're going to divide the numbers outside the radical separate from the numbers inside the radical. Surprise, surprise. Ready? 6 divided by 3. 6 divided by 3 is 2. Square root 8 divided by square root 2, you are allowed to divide those. 8 divided by 2, 4. And then we have ourselves a perfect square. We would never leave our answer like this. And so we know that this is just 2 times 2. And so that's going to be 4. I know. I don't know. I think 6th period is the only time.
Found out.
Sorry, guys. Okay, let's do this one. Ready? Negative 9 divided by 3. Negative 3. Oh, you say it's easier, but it's going to get harder. 42 divided by 7. Yeah, we just haven't had to simplify them much. Square root 6, right? And that one is already simplified, actually. We okay there? Negative 3 root 6. Okay, so that is the rules. Those are the rules. That was incorrect grammar. I showed you this yesterday, but it didn't make a whole lot of sense. Today, this makes more sense. All of these have to be checked for your radical to be fully simplified. Okay, the radicand cannot have any perfect squares left. Now, people get confused because they think that that's not simplified because 6 is like an even number, but 6 doesn't have any perfect squares left. So square root 6, that's okay. But square root 24, that would not be okay because there's a perfect square left in there, right? 4. 4 is a perfect square, 4 times 6. The radicand cannot have fractions. So you can't have, like that. That would not be simplified. You would not be done with your problem if there was a fraction in the radicand. And, believe it or not, someone decided that it's not okay to have radicals in the denominator. It's just not okay. So you can't have 3 divided by root 2. Believe it or not, that is not simplified. And I'll teach you how to get the radical out of the denominator momentarily. I know, boo. Okay, did y'all get those down? Radicand has to be simplified. No fractions in the radicand, and no radicals are allowed in the denominator. They're just not allowed. Kind of, Taher, kind of. Okay, when you need to get a radical out of the denominator, we're going to do something called rationalizing the denominator. Say that out loud. Say it. Rationalizing the denominator. What's Euclid? Euclid is a person. Euclidean geometry is what we study. He was a mathematician. Why are y'all asking that? Okay, anyways. So the way we're going to rationalize the denominator is not to square it, because I heard that and that was a good suggestion. We don't want to change the number. We don't want to change the number. We just want to simplify it. So when you square a number, you're changing it. We don't want to change it. So I'm just going to let the cat out of the bag. We're not even going to discover this. I'm just going to tell you how it is. Okay, this is how you rationalize a denominator. You multiply the numerator and the denominator by the radical in the denominator. That's going to get rid of the square root. So you're going to multiply this fraction by a very fancy number 1. Do we all agree that square root 3 divided by square root 3 is just 1? When you multiply something by 1, you're not changing it. So we are not changing the value of this number. We're just rearranging. We're not changing, we're rearranging. Okay? So you take whatever radical is in the denominator and you multiply the top and the bottom by that radical. Let's do it. Ready? Square root 3 times square root 3. Well, that's just 3. That's square root 3 squared. Those undo each other. Square root 3 times square root 3. I didn't mean it to look like I was subtracting. It's multiplying. Square root 3 times square root of 3 is just 3 because the radicals cancel each other out. And then you go across the top. 1 times square root 3 is just 1 root 3. And believe it or not, that is the simplified version, even though it looks a little bit more complicated than what we started with. Square root 3 over 3 would be the answer. Do we have any radicals in the denominator? Nope. Do we have any fractions inside the square root? Nope. So we are simplified. Here's where we just do a lot of practice. Because of time, I'm just going to start working these, and you either watch or you write it down with me. Yes, Anna, I'll do some more. I'll do some more. All right, number 1. Well, this one's easy. This one takes us back to before algebra even. And the way that we're going to simplify this is I know that 2/8 is 1/4. So the answer to number 1 is just square root 5 over 4. So that one was pretty much already done for us. Number 2, number 2, I spy a perfect square. We don't need to rationalize the denominator because the square root of 4 is really just 2. So the answer to number 2 is 3/2. Number 3, I spy another perfect square. The square root of 9 is just 3. The 3's cancel, and the answer to number 3 is actually just square root 5. So those are some little, it's not really tricks, but anytime you see a perfect square, take the square root of it. Turn it into an integer. Okay. Now, remember, you're allowed to divide a number in the radical by a number in the radical. You're allowed to divide radicands. As long as they're both in jail, they're allowed to be divided, okay? So, on number 4, the first thing I would do is I would combine these. I would write it like this. That's totally allowed to divide them. And what is 45 divided by 5? 9, and then that's a perfect square. So the answer to number 4 is 3, plain old 3. Number 5 is one where we actually have to rationalize the denominator. So when you said, can I see that again? Here you go. You're seeing it again right here. Okay? Number 5. There is no other way to get that radical out of the denominator other than to rationalize the denominator. So the way that we rationalize the denominator is we multiply the top and the bottom by the radical that's in the denominator. Remember, square root 2 over square root 2, that's just the number 1. We are just multiplying this by a really fancy number 1. We're going to multiply across the bottom first. Square root 2 times square root 2 is 2. 1 times the square root of 2 is the square root of 2. And now my answer is simplified. We went over this a little bit yesterday, but I don't think that this has sunk in. Remember when we talked about how when you take a radical and you square root it and you square it, they cancel? And this just equals 5? That's the same as writing square root 5 times square root 5. It's just 5. What's the square root of 100 times the square root of 100? Well, it's just 100. What's the square root of 29.5 times the square root of 29.5? Well, it's just 29.5. So I hope that that makes sense. When you multiply the square root of number times itself, the radicals cancel, and you just get the radicand. Okay? Let's try number 6. Now, we cannot treat number 6 like we treated number 4. Do you see the difference? In number 4, 45 is divisible by 5. In number 6, 5 is not divisible by 8. So we have two options. We can simplify it and then rationalize, or we can rationalize and then simplify. Neither option is, didn't like me. Neither option is better than the other. There's not a better answer. I'm going to rationalize first and then I'll simplify later, but you can do it the other way. So rationalizing just means to get that radical out of the denominator. Get it out because it's not allowed there. You're not welcome here. Okay, so we do that by multiplying the top and the bottom by the radical in the denominator. What's square root 8 times square root 8? Well, by golly, it is 8. What's square root 5 times square root 8? It is square root 40. And then we go through our checklist. Are there any perfect squares in the radicand? Yeah, there is. 40 is 4 times 10. And I'm doing it the perfect square way in my head. I don't know which way you're doing it. You're welcome to factor tree it. But I know that 4 is a perfect square. So I know that that's 2 root 10. If you want to go to the side of your page and you want to factor tree 40, that's fine. So now we have 2 root 10 over 8. Are we done? Are we simplified? Not yet. These are going to cancel. 2 eighths is really 1/4. So the final answer to this problem is square root 10 over 4. And that had a few extra steps. How would you simplify first? Let me show you. If we simplified first, we would have done this. We would have said square root 5 over 2 root 2. That would have been step 1. Takes the handwriting a while to catch up. That would have been step 1, factor tree the 8. Then you multiply the top and the bottom not by square root 8. If you were doing it this way, you would multiply the top and the bottom by square root 2. Do you see that? It takes a while. There we go. Okay? You're going to end up with the same answer, square root of 10 over 4. Either way, same answer. Number 7 is disobeying one of the rules because there's a fraction in the radicand, and that is not allowed. So what I would do first is I would separate these because we're allowed to do that. Then we're going to rationalize the denominator because we know we are not allowed to have radicals in that denominator. Square root 3 times square root 3 is 3. Square root 2 times square root 3 is square root 6. And we are done with number 7. Number 8. Some people get confused on number 8. Do I multiply the top and the bottom by 2 root 6? Or do I multiply the top and the bottom by root 6? You only multiply the top and the bottom by the radical in the denominator. If you multiply it by 2 root 6, you won't be wrong, but you'll just have to simplify way more at the end. And we don't want to do that, okay? So, let's do the bottom first. 2, the 2's already there on the bottom. What's square root 6 times square root 6? Oh, it's just 6, because remember the square roots cancel. And then the top is just 3 root 6. So we have some work to do. This is 3 root 6 over 12. That cancels. 3/12 is 1/4. So the final answer is square root 6 over 4. Can you check these in your calculator? You absolutely can. You can go to your calculator and do 3 divided by, parentheses, 2 root 6, parentheses closed, and it'll get you an ugly decimal. Then do square root of 6 divided by 4, and it should get you the same ugly decimal both times. So yes, you can check these in your calculator if you were wondering. Number 9, I recommend that you split all of those up. Split them up. All right, I'm going to simplify the top a little bit first. You don't have to do it this way. 49 is a perfect square. It's 7. A to the 6th is a perfect square. It's a to the 3rd, because we know that when we square root an exponent, we're just dividing it by 2. And so I've got 7a cubed over root 6. And now I have to rationalize the denominator because that root 6 is not welcome there. Square root 6 times square root 6 is plain old 6. And then we literally have 7a cubed root 6 in our numerator. And that is the final answer on number 9. Woo! That is the end of this lesson. Please, please, please practice your homework. Practice last night's, practice tonight's. Tonight's is way shorter, but you need practice with these radicals. Have a good day.